In this recording, we're going to discuss body fluids. So when we use the term body fluids, we're really referring to all of the water-based liquids within the body. This includes your blood plasma, your interstitial fluids, things like that. Now, water in and of itself has several different functions. One being it is a polar solvent, which allows the water to transport and deliver large numbers of solutes throughout the body that are dissolved within the water itself. Water is also good at distributing body heat. Okay, so it helps us regulate our body temperature. It cushions our organs and tissues, and it lubricates organs and tissues as we move around. So we've talked a lot about things like synovial fluid in your movable joints. That's water-based. We have multiple factors that impact fluid balance. Some of these include the water that you ingest, okay, the amount of physical activity that you partake in, how well your kidneys are functioning, what kind of medications you're taking, and your digestive activities. So the body fluids within your body are really broken down into two categories, two compartments. We've got intracellular fluid, or ICF, and we have extracellular fluid, or ECF. Now, these words are pretty self-explanatory. Your intracellular fluid is going to be the fluid within the cells themselves. Now, here's an interesting fact, though. We know that cells are really tiny, so it may shock you to learn that this is approximately 60% of all of the fluids in the body, or your intracellular fluids, which is a lot, right? And cells are tiny, but don't forget, you have trillions of cells, okay? So all of those cells combined, all of that cytosol accounts for approximately 60% of your body fluids, or about 26 liters, okay? So think of a 2-liter bottle of Coca-Cola or your favorite soda. 26 liters of fluid can be found within your trillions of tiny little cells. Now, anything that is not in the cell themselves, that is your extracellular fluid. Okay. We have two main components. Your blood plasma, that's about 8%, about 3 liters. And then your interstitial fluid, so the fluid within the tissues, that's about 32%, or 13 more liters. That counts for the majority, okay? So 68, so that's about 100%, but you do have just a little bit in these other places. Lymph fluid, cerebrospinal fluid, synovial fluid, your aqueous and vitreous humors of your eye, the little bit of fluid in your ears, filtrate from the glomeruli. All of that counts as extracellular fluid as well, but it's just such a small amount that it kind of gets grouped together as other. Okay. All right, we can kind of see here what we're talking about. The cytosol, so within the cells, that's about our 60%. The blue interstitial fluids, so what's in the tissues, between the tissues, that's our 32%. And then we've got our plasma of the blood, it's about 8%. All right. Now, how do we determine intracellular, extracellular? Well, there are cell membranes that provide that dividing line. Okay, we've been talking about cell membranes forever. You're an expert on those at this point. Although fluids within each of these two compartments, your ECF and your ICF, they stay relatively stable, so we say that there's no bulk transport. Okay, that doesn't mean the fluids don't move at all, because they do. Okay, so fluids do move between the ECF and the ICF constantly. Actually, we do osmosis, we do diffusion, things like that. But what we're really just saying is, again, it's no bulk transport, so we don't have large amounts of fluid movement between these two compartments. Okay. Fluid balance happens when the appropriate amount of water is distributed between these compartments based on what your body needs. Osmosis is how we primarily transport water between the ECF and the ICF. And the really determining factor for which way the water is going to move is actually based on the concentration of solutes within the ECF and the ICF. And so, again, we're going to have movement of fluids, of water, between the ECF and the ICF, okay, constant, okay. We are going to determine which way the water is going to move based on the concentration of solutes in these two compartments, okay, so that's how osmosis works. Now, your total body water, okay, so we kind of talked about, let's go back a couple slides. Okay, so we talked about intracellular, extracellular, 26 liters here, 3 liters there, 13 liters there, and then that's cool, okay? But out of all that water, okay, an average man, an average male, is approximately 60% water by volume compared to his weight, okay? But that's just an average, okay? So normal range is anywhere between 45 to 75% water. And there are certain things that will determine, okay, what your personal normal range would be. So first thing is water content decreases with age, okay? So as you get older, you don't have as much water within your body. The 60%, we said that was for males. So males have more water content than females do, okay? So the normal range for females would be a little bit lower. The percent water decreases as your percent body fat increases because fat doesn't contain water, okay? So the more fat you have on your body, the less water you have. And then vice versa, the percent water increases as muscles increase because muscle does contain water, okay? So all of these things work together to kind of determine what your own personal normal range is. So to remain hydrated, okay, and everybody knows it's bad to be dehydrated, right? Everybody wants to drink their waters and their Gatorades and things like that. To remain hydrated, okay, water input should equal water output. Both of those volumes should be approximately 2.5 liters of fluid. Okay? Now, our fluid intake, okay, and this 2.5 liters, we're referring to a healthy adult. Okay, so children don't necessarily need 2.5 liters, okay, of fluid a day, things like that. So healthy adult. Now, the fluid intake, okay, the biggest contributor is called performed water. Okay, so this is basically water that we ingest. Now, the water that we ingest from just straight liquids, so you drinking a bottle of water. Okay, that accounts for about 60% of your daily allowance, which is approximately 1,500 milliliters. Okay. You also ingest liquids in the form of food. Okay, so think of a lot of fruits and vegetables. They have really high water content. Okay, so that counts. That's another approximately 750 milliliters, or about 30% daily. And you will notice that this is not 100% yet, so we have just a little bit more, 10%, coming from what we refer to as metabolic water. Okay? And this one's kind of weird, but it's my favorite. Your body actually makes water. Okay? We do cellular respiration, cellular metabolism. We take glucose, which this is the chemical formula for glucose, and we take oxygen. Okay? We're really trying to make ATP from that. That's our goal. That's why we're doing it. We make carbon dioxide as a byproduct, but look, we also make water. Okay, so your body literally makes water. I just think that's so cool. Now, it doesn't make a whole lot. This is only about 250 milliliters a day, or that lasts 10% daily. But I just think it's cool. Your body makes water. Okay, so besides the fact that we just know we need to drink water, okay, what drives our water intake? It's our thirst mechanism, okay? And that can be initiated, okay, or kind of turned on by decreased saliva flow, okay, which leads to dry mucosa of the mouth and the larynx. So basically your mouth gets dry and you're like, oh, I think I should drink some water. or increased blood osmotic pressure, your BOP. Everybody knows I love the BOP. Okay. This stimulates osmoreceptors, okay, in the thirst center of your good old hypothalamus, which causes ADH to be released, antidiuretic hormone. Antidiuretic hormone will act on the distal convoluted tubule specifically of the kidney, so the DCT specifically. Okay. This helps us retain water. Okay. Both the dry mouth and those osmoreceptors also activate that thirsty sensation that we get, right? So again, think about the last time you had a dry mouth. What was your immediate thought once you recognize that? You're like, oh, I need to drink something, okay? So these two things are working together to really activate that thirsty sensation, which motivates us to drink fluids. Now, we said fluid output should equal input, and input was about 2.5 liters or 2,500 milliliters, so that's what fluid output should also be. The majority of that's going to come in the form of urine from your kidneys. That probably doesn't shock anybody. That accounts for approximately 1,500 milliliters a day, or 1.5 liters of urine. And then we have three other main ways of fluid output. We have the skin. Okay, so evaporation of water from sweating. Okay, that's about 200 milliliters a day. And we do this even when it's not necessarily super hot outside. Okay, your lungs. Okay, so most people don't necessarily immediately connect their lungs with fluid output, but the air that you breathe out, okay, during expiration is moist, because it's coming from those membranes within the body. And so that little bit of moist air accounts for about 700 milliliters of fluid a day. And then your GI tract, we have previously learned that feces, okay, contain water. Not a whole lot of water, only about 100 milliliters per day. Okay. But if we add all these up, that gets us our roughly 2,500 milliliters a day. And notice that these are just approximations. Okay, everybody's a little bit different. Some days we drink a little bit more water, some days we drink a little bit less. Okay, these are just averages. So we should probably regulate this. Okay. Our favorite way to regulate most things in our body is through either your nervous system or your endocrine system. So here we've got your good old endocrine system. We've got ADH and aldosterone. We are almost experts, hopefully, if not already experts, on ADH and aldosterone by now, but just to remind yourselves. Antidiuretic hormone increases water reabsorption from the distal convoluted tubule, as well as your collecting tubules or collecting ducts. Okay. This decreases urine output, so this helps us retain water. Okay. Aldosterone works by increasing sodium reabsorption from the distal tubule and the collecting tubules, and water follows passively. Okay, so we are reabsorbing sodium, we're also going to be reabsorbing water. This again decreases urine output, so we retain more water for our bodies. Hyperventilation, so we just mentioned that we do lose a little bit of fluids every time we expirate, and so if we extra expirate, I guess you could say, this would increase the output of the fluids via the evaporation, okay, of the lungs, from the water from the lungs. So again, that moist air that we are breathing out, if we breathe out a little bit more, we're going to lose a little extra fluid. Vomiting and diarrhea, okay, I think that one's fairly self-explanatory, but the problem with this is not only are you losing fluids, but you could also be losing proteins and other solutes from your digestive tract as well. Okay. And then fevers or burns, okay, this increases the fluid loss through the skin. So if you've ever had a fever and they always say like, oh, your fever broke, that usually involves sweating, so that would help you lose extra fluids as well. And here we go, just to compare input and output. Notice the totals should be the same, 2.5 liters. This is just to remind us where our liquids came from. Okay, so ingested liquids, ingested foods that have liquids, and then the water that we make in our bodies. And then how we're going to lose that fluid. Most of it's urine, a little bit in feces, some through your skin, and some from your lungs.